In this lesson, we look at an example of linear programming in which we can only have integer solutions. A construction needs to be able to support at least 4 units of lateral load and at least 10 units of vertical load. Steel beams weigh 50 kilograms and they support 1 unit of lateral load and 5 units of vertical load. Wooden beams weigh 30 kilograms and they support 2 units of lateral load and 2 units of vertical load. We can summarize this information in a table. The constraints are that we must support at least 4 units of lateral load, so greater than or equal to 4, and at least 10 units of vertical load, so greater than or equal to 10. We wish to find the optimal combination of beams that supports the required load but minimizes the weight. We will call the number of steel beams X and the number of wooden beams Y. We will make the constraint equations 1x plus 2y is greater than or equal to 4 and 5x plus 2y is greater than or equal to 10. The objective function is the weight which we wish to minimize. It is 50x plus 30y. We will sketch these constraint equations by finding the x and y intercepts. In the first equation, the x-intercept is 4 divided by 1 equals 4, and the y-intercept is 4 divided by 2 equals 2. In the second equation, 10 divided by 5 equals 2, and 10 divided by 2 equals 5. The greater than or equal to symbol tells us to shade above the line. The same is true for the second equation. Therefore, the feasible region is above both lines. We now substitute the vertices of the feasible region into the objective function. We have 0, 5, 4, 0, and 1.5, 1.25. When x equals 0, y equals 5, we have 50 times 0 plus 30 times 5 equals 150. When x equals 4, y equals 0, we have 50 times 4 plus 30 times 0 equals 200. X and y are the number of each beam we will use in the construction. We must use an integer solution. This means that we must have a solution that contains only whole numbers. 1.5 and 1.25 are both decimal numbers, so we cannot use this solution. Instead, we look at whole number coordinates that are near to this decimal vertex. These whole numbers must lie inside the feasible region. For example, we could try 2, 2. We could also try 3, 1 and 1, 3. Since we wish to minimize the weight, we will not try any other larger values such as 2, 3 or 3, 3, since these will definitely be heavier than 1, 3, 2, 2 and 3, 3. When x equals 2, y equals 2, 50 times 2 plus 30 times 2 equals 160. When x equals 3, y equals 1, 50 times 3 plus 30 times 1 equals 180. When x equals 1, y equals 3, 50 times 1 plus 30 times 3 equals 140. 140 is the lowest weight solution, so we use 1 steel beam and 3 wooden beams to do this. Visit mathsathome.com for further videos and practice.